My name is Tobias, and today we're going to look at sums and sigma notation. So here we have some examples using sigma notation. So the first one, example 1, here we've got our big sigma, the Greek letter for S, and we've got our index I, and we've got our lower limit here, which is 1, we've got our upper limit, which is 10, and we've got our expression in here, which is just an I, so equal to our index. And the sigma notation means that we start by using our lower limit down here and putting that onto i's place in our expression. And since it's only I here, we just say 1. We put a 1 onto i's place, so we start by 1. Then the sigma notation is a notation for sums, so we have to say plus. And then we take the next natural number, which is 2, and then we take the next plus 3, plus 4, plus 5, and all the way up to 10, which is our upper limit. So instead of writing 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, we could just write it as compactly as this expression using sigma notation. We've got a second example here. Our index is still I, our lower limit is still 1, our upper limit is 10, and now our expression has changed a little bit. So it's I squared. So we start by putting our lower limit onto i's place, so it's it's a 1 squared. Then the sigma notation once again is for sum, so we say plus, then we say 2 squared plus 3 squared plus 4 squared plus all the way up to 10 squared. So we put in the natural numbers onto i's place and we have to square them every time. So instead of writing this sum, we could just have written it as this sigma notation, where we've got this expression, upper limit, lower limit, and index. We could also do it with I cubed, so almost the same. We just have another expression in here, which is I cubed. So we start by 1, 1 cubed, plus 2 cubed, plus 3 cubed, all the way up to 10 cubed, because 10 is our upper limit. So this is where I was cubed, our index. So then we get this sum, which could be written as this, as compactly as we want to. Then we've got example 4. This time the upper limit is changed to 100. The expression in here is just I, so a little bit less difficult than this one up here. So like we started. And this time we go up to 100. So we say 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100, because that's our upper limit. So that would have been a lot of numbers put together and added to another, but we could just have written it as this expression instead. So it takes less time to write up, and if we know this notation, it's good for us to just use this instead of writing all these numbers every time. Example 5. This time the expression is 1 divided by n. Our index is now called n. Our upper limit is 6. So we start by putting a 1, because that's our lower limit, onto n's place. So it's 1 divided by 1, plus 1 divided by 2, plus 1 divided by 3, plus 1 divided by 4, because we have to put our numbers onto n's place every time. So we get these 6 fractions. We end by 1 divided by 6, because that's our upper limit. So now we've got our expression here, our sum, which was calculated using this sigma notation. Example 6, almost the same. The index is n. The upper limit is once again 6. Now we've got the expression 1 divided by 2 to the power of n. So we start by putting 1 onto n's place, then 2, then 3, and so on up to 6. So it's first 1 divided by 2 to the power of 1. Then it's 1 divided by 2 squared, 1 divided by 2 cubed, 1 divided by 2 to the power of 4, 1 divided by 2 to the power of 5, plus 1 divided by 2 to the power of 6. And instead of writing all this, we could have just written it as this. Example 7. So this time we've got our upper limit, it's 5. Once again we are using the index I, and this time it's just 2 to the power of I. So we just say 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power 3 plus 2 to the power 4 plus 2 to the power 5. So we always have to look at where is our index at in this expression, and we have to put in the natural numbers starting from the lower limit up to the upper limit. So we get this expression from this notation. Example 8, a bit more complicated. The index is k this time, the upper limit is 5, the lower limit is 1. This is our expression, so we say 1 divided by 1 squared plus 1 cubed, because we have to put 1 onto k's places here, which was the first fraction. Then we say plus because of the sigma notation, 1 divided by 2 squared plus 2 cubed, plus 1 divided by 3 squared plus 3 cubed, plus 1 divided by 4 squared plus 4 cubed, and plus 1 divided by 5 squared plus 5 cubed. So once again, we could have written it just as this, instead of writing all of this. Example 9 is from statistics, so we can calculate the mean of some values. So this expression is this time with a constant outside our sigma notation, so 1 divided by n. We have this expression using x values, and we've got an index down here for that's I, and the index here is also I. We start the lower limit at 1, and our upper limit is a finite number called n this time. So we have to put in 1 first on i's place, then 2, then 3, and all the way up to n. But because 1 divided by n is outside the sigma notation, we have to write it outside some parentheses where we now write our expression. So we start by saying x1, that's the first term inside these parentheses. Then we say plus x2 plus x3 plus x4 plus all the way up to xn, which is our last value here because of the upper limit. So x1 plus x2 plus x3 are just values for x. So that could have been some values in statistics we had used there. I don't know, something else. And when we have something that is multiplied onto a fraction, we always multiply it up on the numerator up here. So we put all of this up here. Then we got this fraction x1 plus x2 plus x3 all the way up to xn divided by n, which was down here. And that is the same way as calculating our mean for some values of x. So if we had had some x values from 1 all the way up to n, we could have divided by the number n, and we could have calculated our mean of some values for x. The example 10 is actually just the same as up here, we just have a y instead. So this time we have the expression y with an index I, and we do all the same things that we did in example 9. So first off, 1 divided by n, that's outside our expression, and then we use our sigma notation to put all these values into our parentheses. So that's first y1 plus y2 plus y3 all the way up to yn. Then we multiply it up onto the numerator up here, and then we've got this new expression with the numerator and the denominator down here, and that's the same as calculating the mean for our y values. So that's another way of calculating our mean, just using sigma notation. So that was the 10 examples I've got for today. Thanks for watching. See you in my next video. Bye bye.